students, today we discuss about projectile motion. First of all, what is projectile? Projectile means when a body is projected in air in any direction is called as projectile. What are the examples of projectile? So, examples means first example, when a body is dropped from an aeroplane, it is also a projectile. Second example, a gun is fired from a bullet, it is also one of the example of projectile. Here bullet is one of the projectile. So now, in the case of projectile motion, there are two types. First one is oblique projectile motion. Second one is horizontal projectile. So now we discuss about oblique projectile motion. Okay. Now, an object is projected into air with some initial velocity u, making an angle theta with the horizontal. So here this is one of the object. That object is a ball. A ball is projected into air with initial velocity u, it's making an angle theta with the horizontal. So in the case of projectile, in the case of oblique projectile, its path followed by the object in this way. So here this is the projection point. So that is O. So here theta is the angle of projection. So here path is O A B. Here OAB is the trajectory path. What is trajectory? Means the path followed by the projectile is known as trajectory. So this is the trajectory. So now the initial velocity of the projectile is here. This is the u bar. Here u bar is resolved into two rectangular components. So one is horizontal component, it is treated as ux. Another one is vertical component, that is the uy. So in this situation, horizontal component velocity remains constant in this path, because in this case the unaffected gravity acting on the horizontal component. So here horizontal component velocity remains constant at any point in the path, but here uy means vertical component of velocity is affected on gravity. So here vertical velocity component is at the initial is maximum, but and then it gradually decreases. At maxima its value is 0, and then it gradually increases till at the end of the earth surface. To reach the earth surface, its value is maximum. Now in the case of vertical direction, there is an acceleration, because here u sin theta term is changes with respect to time. But in the case of horizontal direction, there is no acceleration, because when a body is moving in horizontal direction, unaffected gravity. So horizontal velocity component is remains constant. So along horizontal direction there is no acceleration. So in this situation, ux means u cos theta. So it is a horizontal component velocity along x-axis, and the vertical component velocity u sin theta along vertical direction, so along the direction of y-axis. Now with respect to origin, after time t seconds, the projectile to reach some point p, so here its final velocity, horizontal velocity vx. So this is v by, so here resultant velocity v, it's making an angle alpha with x-axis is alpha. Okay. Now we can find out equation of trajectory. Equation of trajectory. So this is the diagram. So here after t seconds it reached the point P. This is the Vx, Vy. So this is the V. It's making an angle alpha with x-axis. So now displacement covered by the particle, displacement covered by the projectile after t seconds. So along horizontal direction there are two cases are there. Case 1, along horizontal direction, So here initial velocity ux equal to u cos theta. Acceleration ax equal to 0. Why? Because in along horizontal direction there is no acceleration because of unaffected of gravity. So here ax equal to 0. So u cos theta term is remains constant in any point of the parabola. So time in and distance s equal to x. So along horizontal direction, so the distance traveled by the projectile is x. So this one, this is the x. Along vertical direction, it covers displacement is y. Okay. Now using the equation, s equal to ut plus of at square. So here s is treated as x. Here ut means u cos theta into t plus here of at square, that means of ax into t square. So here ax equal to 0. So along horizontal direction there is no acceleration. So therefore x equal to u cos theta into t. So therefore t equal to x by u cos theta. This is equation number 1. Now along vertical direction, case 2. Along vertical direction. So in the case of vertical direction, initial vertical velocity, that is uy means u sin theta, and acceleration ay equal to minus g. Why? Because so in vertical direction, acceleration due to gravity a equal to minus g. So next, displacement sy is treated as y. Time taken t equal to t. Now using the equation v square s equal to ut plus of at square. So using the equation is s equal to ut plus of at square. So here s means vertical distance covered by the particle after t seconds. So this is y. So y equal to ut uy into t plus of a means ay into t square. So now y equal to uy means u sin theta into t, ay means minus g minus of g t square. Now equation 1 substitute in equation 2. So this is the equation number 2. So therefore y equal to u sin theta into t means x by u cos theta minus of g t square x square by u square cos square theta. So now y equal to u cancel, sin theta by cos theta, tan theta into x minus g by 2u square cos square theta into x square. So this is the final equation. In the final equation, let a equal to tan theta and b equal to g by 2u square cos square theta. So here a and b are the constants. A and b are the constants. So therefore, given equation can be written as y equal to ax minus bx square. Y equal to ax minus bx square. So here y equal to ax minus bx square, this equation is represented by the parabola. So this equation is represented by the parabola. So now the path of the trajectory is a parabola. Hence the path of the trajectory is a parabola. Okay. Now, in the case of oblique projectile, velocity after time t seconds. So here, instantaneous velocity of the projectile at a time t seconds. So this one. So we can find out the magnitude of the v bar. So here in this case, v bar equal to vx I cap plus vy j cap. So here along horizontal direction, along vertical, so along horizontal direction. So here final velocity, that is v, initial velocity, that is ux, u cos theta, its final velocity is v. Acceleration ax equal to 0 and time t. Okay. So along vertical direction, final velocity, that is the vy, and initial velocity, that is uy, u sin theta. Acceleration ay equal to minus g and time t. So these values is substituted in the equation. So here along HD means horizontal direction, using the formula v equal to u plus at. So here along horizontal direction final velocity is vx equal to ux plus ax into t. So now Vx equal to ux means u cos theta plus, here along horizontal direction there is no acceleration, so 0 into t. So therefore Vx equal to u cos theta. So this is one, equation 1. Now along vertical direction, second one, along vertical direction, using the equation v equal to u plus at. So here along vertical direction, that is vy, so initial velocity uy and acceleration ay into t. So here vy is equal to uy means u sin theta. Here ay is minus g, so minus g into t. Okay, so this is the vy. Now you can find out the magnitude of the v. So therefore v equal to vx I cap plus vy j cap. So here vx means u cos theta into I cap plus vy means u sin theta minus gt into j cap. So now we can find out the magnitude of v. So this is the v bar. We can find out magnitude of v bar is, so that is modulus of v bar equal to root over vx square plus vy square. So modulus of v means v equal to root over vx, this is the v bar. Vx means u cos theta whole square plus vy means u sin theta minus gt whole square. Now it can be calculated that so v equal to u square cos square theta plus, so it is in the form of a minus b whole square, a square, that means u square sin square theta plus, so that means a square plus b square means g square t square minus 2ab, 2a means u sin theta and b is gt. So here b equal to root over u square common this time, sin square theta plus cos square theta plus g square t square minus 2u sin theta into gt. So b equal to sin square theta plus cos square theta equal to 1. So therefore u square plus g square t square minus 2u sin theta into gt. So this is the magnitude of v bar. Now we can find out direction of v bar. Next one is direction of v bar. So here angle is making an angle with the x-axis alpha, so tan alpha equal to vy by vx. Vy means u sin theta minus gt by vx means u cos theta. So therefore alpha equal to tan inverse u sin theta minus gt by u cos theta. This is the direction of V bar. Now, in the case of oblique projectile motion, some parameters are there. So, first of all, in the case of oblique projectile motion, time of ascent. What is the equation of time of ascent? It is denoted by letter T. So, time of ascent means the time taken by the projectile to reach maximum height is called as time of ascent. So, in this case, final velocity, that is V equal to 0. So, final velocity means at a maximum height its velocity, vertical velocity component is 0, and initial velocity uy, that is u sin theta, and acceleration along vertical direction, acceleration, that is ay equal to minus g, and time t equal to ta. Now, using the equation v equal to u plus at, so here final velocity at maximum at 0 is equal to u means u sin theta, here a means minus g into ta. So therefore gta is equal to u sin theta. Therefore ta equal to u sin theta by g. So this is the time of ascent in the case of oblique projectile motion. Now, time of descent in the case of oblique projectile motion. Second one is time of descent. Okay. So in the case of time of descent means the time taken by the body or projectile to reach earth surface from the maximum height. Maximum height నుంచి earth surface కు reach అయ్యే time నే మనం time of descent గా treat చేస్తాం. So therefore in the case of TD equal to root over 2h by g. Here h means maximum height. H means maximum height. So in the case of oblique projectile, maximum height is u square sin square theta by 2g. Okay, we know that. So h max equal to u square sin square theta by 2g. So now this value is substituted in the above equation. So therefore TD equal to root over 2h, h maximum means u square sin square theta by 2g into g. This one. So here 2 cancel. So that means u square sin square theta by g square. So u sin theta by g. U sin theta by g. So this is the expression for time of descent in the case of oblique projectile motion. Now we find out maximum height in the case of oblique projectile motion. Maximum height. What is maximum height? Maximum height means it is defined as maximum vertical distance covered by the projectile is called as maximum height. So now in this case initial velocity uy equal to u sin theta, because vertical direction means along y axis, so initial velocity is vertical component is are taken. So final velocity v equal to 0, acceleration equal to minus g, displacement s equal to h max. So now using the formula v square minus u square equal to 2as. Here v means final velocity 0 square minus u means u sin theta whole square is equal to 2a. A means minus g. Here s means h maximum. Now it can be written as minus u square sin square theta is equal to minus 2g h maximum. So here minus minus cancel. So h maximum is equal to u square sin square theta by 2g. So this is the expression for maximum height in the case of oblique projectile motion. Now we can find out range, horizontal range in the case of oblique projectile motion. Fourth one, horizontal range. It is denoted by letter capital R. What is horizontal range? Horizontal range means the maximum horizontal distance traveled by the projectile during its time of flight. So time of flight time lo మనం తీసుకున్న projectile horizontal maximum horizontal distance ఏదైతే ఉందో దాన్నే మనం range గా ట్రీట్ చేస్తాం. So in the case of horizontal motion, so therefore initial velocity ux u cos theta, displacement s equal to r, acceleration ax equal to 0. Next time t equal to capital T. So capital T means time of flight. Okay. So what is time of flight? Time of flight means the sum of the time of ascent and time of descent. So that is TA plus T. So here T equal to time of ascent u sin theta by g plus time of descent u sin theta by g. So now time of flight T equal to 2u sin theta by g. Okay. Now this value is substituted in time taken. So therefore using the formula s equal to ut plus half at square. Okay. Therefore s means r equal to u means u cos theta into capital T plus of ax into capital T square. So in this situation, along horizontal direction there is no acceleration, so ax equal to 0. So therefore range equal to u cos theta into, here time of flight is 2u sin theta by g. Okay, so therefore range r equal to, so u into u square, that means 2u square, so here u square 2 sin theta cos theta by g. So it can be written as r equal to u square. We know that 2 sin theta cos theta is equal to sin 2 theta, sin 2 theta by g. This is the horizontal range, expression of horizontal range in the case of oblique projectile motion. Okay, thank you.